All right, so here I'm going to do number 52, and for homework you'll be doing 51 and 53. So here's a more realistic scenario. This is just an example that leads up to more realistic problems. So here we're going to find the coordinates of the points where the diagonals of the quadrilaterals intersect. Now for these, it could take some time depending on how you do it. But the general gist for all of these is you need to find the equation of the red lines. So it's going to require some work. And so in order to find and you could do some other trickery because they're whole numbers, but we're going to do it just in case you have to deal with decimal numbers in the future. With whole numbers, sometimes you can work your way by counting the slope and whatnot. That's true. But we're going to actually do it because if you had like 1.23 as a point and 2.68 and variety of decimals, that would be very difficult. So we want to know the method using easier coordinates. So if you can guess what that coordinate is, well done. But we're going to actually do it the way that is required. And that is to find the equation of the lines. So notice in order to find the intersection of two lines, I need to know what the equation of the lines are. In order to find the equation of any line, I have three ways I can do it. If you remember, I could use the slope-intercept form, the point-slope form, and also utilizing the concept of finding the slope. And so that's what we're going to do here. We first need to find the equation of the first one. We could call this line 1, and then the other one, line 2. So with line 1, just put L1 there. For line 1, we have 2 points, and we're going to find the gradient or slope of that line. So first, to find it, we have y2 subtract y1 over x2 subtract x1. Remember, your y2 would be these ones. This is your x2 and y2. So we're going to have 6 from the y2 minus y1, which is 1 over here. These 2 points is what gives us line 1. And then 6 minus 1. 6 minus 1 is 5, and 5. So that's 1. So to find the equation of line 1, we could use either the slope or we could use point slope form. If we use point slope form, we have y subtract y1, and you could choose any of the points. Of course, using 1, 1, it would be easier. So y subtract 1 equals to m, which is 1, x minus x1, which is also 1. That can quickly simplify to y is equal to 1x subtract 1. If you add the 1, you get x. And you could have just saw that by saying 1166 means is y equals to x. But like I said, we're going to go through the whole concept. So we know that the first equation now that we've picked is going to represent y equals to x. So we know this one is y equals to x. All right, then we need to find the other one, L2. And if I change the color for that, it might stand out better. All right, so L2 is going to be the other 2 points. And that way we can find the equation of the other line that crosses. So L2, we do our slope, y2 take away y1. So that would be 2 subtract 4 over x2 is 6 subtract 0. And so 2 subtract 4 is negative 2. 6 subtract 0 is 6. And so if we reduce that, it will be negative 1 over 3. All right, so now that we have our slope, we could use the point slope formula. So y subtract y1 would be easier to choose the 0, 4. And so y subtract 4, that's our y, is equal to m, which is negative a third, times the x. The x here is 0. Sorry, the x1 is 0. We have to write x first. So we have x subtract 0. When we simplify that, we're going to have y is equal to, if you distribute this in, a negative third x. The 0 is gone, and if we bring the 4 over as a positive 4, we have our other solution. Okay, so now that we've done that, I should have wrote a bit smaller, but we can now take this and solve for our intersection. And we have 2 ways we can do that. We can either substitute or do the linear combination, or also known as the elimination method. Because we just have y equals to x, we can just substitute. And so if I substitute y equals to x, I can either substitute the y's in, x for y or x, either or, doesn't matter. So let's write it so that we have x equals to negative 1/3 x plus 4. Right, so we want the x's together, so we're going to have x plus 1/3 x. And because I'm just going to do it all in one step, it's the same as 3 over 3x plus 1/3 x equals to 4. All right, so that's going to give us 4 over 3x equals to 4. And remember, you can multiply by the reciprocal. And I'm hitting buttons now. But if we multiply by the reciprocal, it cancels. And on the other side, it's 3 over 4. So those cancel and you're left with x is equal to 3. So we can see that 3 would be the x value there. And to find the y value, well, because this y equals to x, that means it's also 3. So y equals to 3, right, if we substitute it into there. And so that cross section, the intersection of those two lines is 3, 3. And you want to go ahead and try 51 and 53. Yes, they're whole numbers and integers, so you could possibly do it without the algebra part, but you do want to practice the algebra because these type of questions can be common, especially as you go further on in mathematics. All right, so here we have example 5. This is using a linear system in real life. And so for this one, once again, we're going to solve it algebraically. The other one that we just did was a combination of algebra and graphing, whereas this one is just pure graphing. Sorry, pure algebra. So it says a caterer is planning a party for 64 people. That's one total already. The customer has $150 to spend. So already you know what your two totals are to get your linear system. You have one dealing with the total amount of people, and one is going to deal with the total money. All right, then it says a $39 pan of pasta feeds 14 people, and a $12 sandwich tray feeds 6 people. So you want to get your money together, and you need to you see that you're dealing with pastas and sandwiches. So X would be, let's just go with the first one, pasta, and Y represents the amount of sandwiches, trays. So these are sandwich trays and pasta trays. All right, so how many for money? I have $39 pan of pasta, so 39x plus $12 per sandwich tray, so that's 12y. And that's going to equal to the total amount of money, $150 that I have to spend. But then I need to see how much each tray feeds per person, and 14 people can be fed by the pans of pasta, so 14x, and then $12 sandwich tray feeds 6 people, so 6y for sandwiches, and there are a total of 64 people. So now we have a linear system, and we could go ahead and solve, and already you should be able to see that these two are multiples of each other. And so if you multiply 6y by something to get to 12, you could go ahead and solve that. So timesing it by negative to make sure they cancel when we add 2 will allow us to do that. So negative 2 times 14 is going to give us negative 28. X subtract 12, y equals to 128. All right, so then we need to do the other one. This one can stay. So 39x plus 12y equals to 150. And we can just add everywhere because we're adding to cancel this here. And then we can combine everything else. So negative 28 plus 39 is going to give us 11x equals to 128 plus 150. And, oh, sorry, that's a negative. I must have left that out because we multiply by a negative. So negative 128 plus 150 is going to give us 22. And then divide both sides by 11. And so x is going to be equal to 2. So we just want 2 pans of pasta. All right, and then we're going to take that 2 and substitute it into one of the original equations. And since the first one has smaller numbers, I'm choosing that. So 14 and x is going to be 2 plus 6y equals to 64. All right, so 14 times 2 is 28, plus the 6y equals to 64. We're going to subtract on both sides, so 6y is equal to 64, subtract 28, and hopefully you can do that one in your head as well. That's what I'm going to do. So that's going to take us down to 36. Okay, and divide both sides by 6, and you're going to get y is actually equal to 6. So that means, and whenever you deal with word questions, you should give a worded response. So we're going to have two pasta. We're going to have two pastas because that's our axis. So 2 trays of pasta and 6 trays of sandwiches. And so you can see if you were asked to optimize the amount of things that are needed at a restaurant, a party, or something, you could use your mathematics skills to make sure exactly how much you needed. 2 trays of pasta and 6 trays of sandwiches.